Hi and welcome to a Christmas 2019 build video. Now this is a kit from Banggood. This was purchased by myself. Banggood didn't supply it or anything. The total cost of the kit was £9.90 plus 20 pence in shipping, so a combined cost of £10 and 10 pence. So what do we have here? We have a battery holder, some hardware, a load of acrylic panels, and here we have some PCBs and a load of components. So if you haven't guessed yet, this is a PCB Christmas tree. This is a PCB Christmas tree kit that you can put together, RGB, and the reason for the acrylic panels is so you can put it in its own little case for protection. Or maybe it's a naughty Christmas tree and needs locking away. So let's just see what we've got here. Now they haven't packaged this the best as they could, unfortunately. It would be nicer if these, they got the LEDs separate there, but yeah, all the components and a couple nuts and bolts there are all just loose. So we get the soldering iron turned on. There's no instructions, but hopefully you can muddle our way through and see what this thing's like. Now, before we continue with putting this kit together, big thank you to my sponsor PCBWay. PCBWay's big Christmas sale is now on. You can get up to 70% off PCB prototype boards and assembly. They've got loads of coupons available and a combined value of $410, so grab yourself a coupon. So now's a great time to get your project off the ground and order your prototype boards. Links to PCBWay are in the description below. So, what do we have? We have 3 PCBs. So these are clearly designed to slot together like so, and then that will go into the base there. So we have a packet full of LEDs. Now this is supposed to be an RGB, so I'm guessing these are going to be just a random mix of different colour LEDs. So I presume if you wanted them in a certain order, you could go through and test each one and see which colour they are. We've got various transistors here. 4 of those, I believe. Hopefully they're all the same. Little DC power jack, very tiny one there. That's more transistors. We've got 6 of those then. We've got a little switch, some electrolytic capacitors, and then a bunch of resistors. So they seem to be, I think, 2 different values we got there, maybe 3. There probably are instructions actually on the website, on PCBWay, sorry, on Banggood's website, but it doesn't come with any in the packet. So having a look on here, transistors 9014, 9014, 9014, and that is 9014, 9014. So the transistors are all the same, so that's nice and simple. And resistors, we've got 4.7k and 100 ohms. So this should be quite an easy kit to put together. So let's get cracking. Okay, so we've got our resistors to go in first. I've picked out all the 4.7ks. They do actually seem to measure about 4.5. I don't think they're very high quality resistors. So we get these placed in the board. So we want all the 4.7s and all of the 100 ohms. Okay, so we've got all of the resistors in on this part of the Christmas tree. So let's just go ahead and solder these down. Now if you don't know what the color code of the resistor is, you can look it up, or you can cheat and use a multimeter and check what the resistance is. And so once you've got them all in on one of them, we can go ahead and solder them all in place. So I think the biggest job on this one is going to be the LEDs, as we have a lot of those to put in. Where are we? One down here. One over here. And one here. Hopefully that is all of those soldered in. So now we just need to trim the leads on those, and we can go on to the, well, I think we'll do the resistors on the second part of the board. So that's all of those resistors soldered on and legs trimmed. I did miss one out, so just soldered that one in. And now we've just got this board here. So there should be, there's only 6 resistors left. So 4.7. So 4.7k there. So we just got another 4.7 there. Should be 3 4.7s and 3 100 ohms. So I'll just get those pushed in and soldered in. So that's all done on that part of the PCB. So now I think we're going to go for the transistors. Now be careful when you're soldering, as I've managed to bridge over one of the holes there for the transistor leg. So I'll need to heat that up a little bit as I push it through. These are quite straightforward. The marking on there, you've got the flat and the curve, so just make sure you line that up with the flat and the curve on the transistors. So we get those in on this board, and I'll get them in on the other board. We'll solder those in and see what's next. And we will now just trim the legs for these ones on the other PCB. You can do them individually or just trim the all 3 in one go. So all we've got left now pretty much is the capacitors and the LEDs. I believe from memory the LEDs, I think they showed them being put in and bent over. I'll double check that on the picture. But I think what we'll do is put all the capacitors in. These do have to go in the right way. They are marked with positive there. So your long lead is your positive and your short is your negative, your ground. So make sure you put them in the right orientation. Otherwise we might have a little bit of a problem when we power it up. So I think we'll get all those caps in, and then I'll check the pictures and see how we're supposed to do the LEDs. Okay, so I've had a look at the pictures on the website, and yes, the LEDs need to be orientated in a outward direction. So I think these are all going to be a mix of random colours, hopefully anyway. And same as capacitors, long lead is the positive, short lead is the ground. So if we put one in there, and then I think what we want to do is get them in so far and then bend them out like so. And so it's a simple process of getting these all in the right direction, bent out like that and soldered in. So we'll just solder that one in now. You might want to use a finer tip on your iron for doing this, and need to get a slightly better cleaning sponge that actually cleans. And yeah, I could do with swapping tips, but I don't know if I can be bothered to wait for the iron to cool down, so we'll see if we can get away with that. So it's just a case of repeating that on all the LEDs on this board and all of the LEDs on that board. So I should be back when that's done. Okay, so that's been a few minutes for me and a fraction of a second for you. Now that means we've now got all of these LEDs soldered in as far as I can tell. What's a bit concerning is we've got 4 left over there. So why have we got 4 left over? And let's have a look on this board again. To me that looks like they're all soldered in. Now on this baseboard, let's say, apart from having 4 LEDs left over, we've got here U1, Q1, buzzer, jumper, Another connector over there. These are all things that don't come with the kit. So is this because this kit is designed to have two functions? Why would we have a buzzer? Is there a version that plays a Christmas tune? I guess it's good it doesn't have it, because that would drive anyone nuts. But yeah, hopefully none of that is actually needed to get this working. So by the looks of it now, we've just got this switch and power jack. So I think we'll put the switch and power jack on, and then we'll try and sandwich these two bits together, and they have to be soldered in, and we'll see if that kind of fixes everything and it works. But yeah, it is interesting why have they got these other options. It may well be, like I say, that possibly they have a version of this kit that plays some really annoying Christmas music on a tiny tinny buzzer, which I can't imagine anybody in their right mind is going to want that. So there's our jack in, and let's get our switch on. But of course you could modify it if you wanted to have such a feature. Then I'm sure you can well, tells you there 8050 transistor. I don't know what U1 is, you'd have to work that out, but you could add it if you wanted to. Now I really should use some lead-free solder. I'm terrible for just using leaded, because I never found it to be too much of a pain to solder, but this new one I've got, cheapo Chinese solder, doesn't seem to flow as nicely as I would like. Okay, so that's our switch on. So I think now it's a case of those two, and then the battery wires, and then putting it in its little case. But of course we want to test it first. Now with these LEDs, you could spend a long time trying to get them all bent at exactly the same size. I haven't really bothered too much with that, but you can tweak them a little bit, sort of up and down, to get it to your liking. So this one must go on here. Now, do they have to go that way around or the other way around? Now if we put it like that, you can see you've got A and B boards, and it's marked positive and ground. So on the PCB, excuse me, we have got that, I think is positive. It shows positive there, negative there. Just wondering, do we do it that way, or is it another way? Let's see. If we rotated it, especially as those components seem to hit that way, does it have to go that way? They seem to hit that way as well, so I'm not too sure. All right, let's have a little look. So positive is marked there, negative is marked there. So that would be positive, that would be negative, that would be positive and negative. I think that's how it goes that way round. Now the next tricky part is going to be to solder these boards in. So I think what we need to do is go from the top, try and get these somewhat lined in. Can we get one? I think what we'll do is we'll do one first. So what I'm going to do is put a little bit of solder on the edge, and then try and make the board up, and then reflow. as well. Hopefully it lines up here. And we'll just make sure that's flush with the board. That looks pretty flush. So now it's going to be a case of awkwardly flowing some soldering on these joints. I can probably do it that way up, I suppose. It doesn't matter too much. So it's just a case now of getting plenty on here so that it sticks properly. And then we'll do it on the rear as well. Now, of course, this is the thing, you do want to do it last, because if you needed to take this board off again, it's going to be a bit difficult to get it out. So positive is there, so I think that slides in like so. And now, because we've got one in, we can get this to lock in pretty easily, and just do the same job of flowing some solder in so that this stays in place. And of course makes a good connection, otherwise it's not going to work. Okay, so that's all connected up. We've got our switch on. It's a bit El Cheapo switch, so be careful with that one. Now we can solder our battery pack. So we've got the option to use the batteries or the little USB lead. So battery wires, positive and negative. Shall we go from the top? I think we will go from the top. Let's strip a bit more off these very, very thin cables. And let's just tin these, I think, just make it a bit easier for getting it in. Yeah, I certainly would have preferred some thicker wires for this battery pack, not because it needs it from the current point of view, but these really are very thin and nasty wires that are probably quite likely to snap off without too much effort. So it might be worth adding some hot glue over the top of those so they don't break in a future date or time. Okay. Now I could go ahead and solder the bottom, but I don't think we need to with that. I think that should be fine. So I think the next job to do is see if we got some batteries, or I will use the USB power bank and make sure it works. Well, I don't appear to have 3 AAAs. I've got 2 AAAs, so I'm not going to worry too much about that. We will try it with this USB lead and this power bank, which is probably the way we want to operate something like this. Has this got any power? Yes. Okay, so let's plug this lead in. Don't know which way the switch is on. Aha. Right, so we have some LEDs working. These must be RGB LEDs themselves then, but we do have that one's, the top one's not working, that one's not working, that one's not working, that one's not working, Oh no, that one is. Hold on. Alright, 1, 2, 3, 4, 5. Alright, we've got 6 LEDs. 1, 2, 3. Have we or have we not? One LED, 2 LED, 3, 4, 5, 6. Okay, so we've got 6 LEDs that aren't working. So have I put these in the wrong way round? I'm not too sure, but I'm going to have to check these and see what's going on. That one's not soldered very well. I think it's soldered enough on that side. Yes, it is. Okay, let's do some investigation. See if I've got these the wrong way around, or if they're dead. Well, I don't think they're the wrong way round. They look okay to me. So let's see, we know this one doesn't work at the end. Let's just probe that with the meter. Let me just zoom out a bit so we can get that in shot, and let's just see if we've got any power going to that one. Alright, it's not measuring anything on that one. Let's measure one that does work. Yeah, so I think the LEDs are fine. So have we got a transistor in the wrong way round or a bad transistor? So let's double check that. So unplug that and have a look. So that one is in the correct orientation. So is that one. That one's correct. That one appears to be correct. I think that's... How many transistors do we have? 1, 2, 3, 4, 5, 6. So let's have a look. .9014, so they are all the same. I haven't looked closely. I can't really read those markings now I put them on. Yeah, that one's a 9014. That one's a little wisp of solder. I don't think it's shorting. Right, let's just reflow some of these transistors and see if that makes any difference or not. Could it be that we've got some bad transistors? I suppose. It's a cheap kit. But I haven't got any, yeah, I really should get the fine point tip out, I think, for this. I mean, the joints look fine, they don't look bad or anything. Just dab these with the iron. The only thing I can think is, have they got the markings actually wrong on the board for the orientation of say 1 or 2 of those transistors. Yeah, they're still dead. Interesting. So what do we think? Leave it in the comments below. Have we got... I mean, would we have 1 transistor controlling some of these? I don't know. We're going to need to do some following of traces. Now that's... You can see the ground of that one goes down to the ground of D6. grounded D6 goes to, yeah, so that grounds right down to there. So what we want to know is, right, let's take D4, right, it's right at the bottom, so we know D4 doesn't work. So now this is one that wasn't actually marked with positive and negative, but if we have a look we can see that positive is the top trace on this LED, and that does go down to positive on that LED. Now the grounds, that's tied through to that resistor R2, and that runs up into, I think, now this resistor R2 feels quite warm in comparison with the other resistors. Let's just measure the voltage across that one. So R2, this is going to be awkward to probe. It's pulsing. So I think that's I think the right signal's going through there from the transistor. So this is a bit of a mystery. It could be that we've got a bad transistor. Yeah, that one's, nothing looks shorted anywhere. It's a case of double checking again and again and again to see if there's anything obvious. Now I'm just wondering that we do have these bits here. Are these supposed to be interconnects? If you have a look, there's no components that go here, but are these supposed to be connected? I'm just wondering if that's what's causing the problem. But even though we're soldered in, I thought these were separate because we've got plus minus plus minus, so I would have thought it wouldn't matter. I don't think. Yeah, there's no traces going off those, so those are obviously just designed to add mechanical strength, so it's got nothing to do with those pads there. Hang about, I've got one LED here that appears to be shorted out. Let's see if we can correct that. I think that one is touching. Alright, let's get the solder sucker. Why are we using the solder sucker? Because the desoldering station doesn't work. I had this problem with it before, the screen just goes dead on it and won't do anything, and unfortunately last time I took it apart, unplugged a few things, plugged it back in, seemed to fix it, but it's dead now, and I'm not gonna, well, I will buy another one when I've got the funds, but not the same one. Okay, so we've taken that out, that little bridge. Let's see if that solved our problems. Yes, all the LEDs are now working as they should. So yeah, these are obviously RGB LEDs. I'm guessing they must just light up a different colour each time they're powered up, I would imagine. If I can find a coin cell battery, we can try it with one of these, see if that's how they operate. Right, so that's fixed our problem. All that's left to do now is to get the case put together and pop it in there for a added protection. Now these are pretty straightforward, just a case of peeling all the backing off. I'm going to get a bit of tape, because that sometimes helps. You can put a bit of tape on there and then pull it off, rather than trying to pick away at the back end pieces. Now this doesn't always work, but sometimes it does. So stick some tape on there. It's not quite strong enough, so what we'll do is peel back an edge if we can. Yeah, this tape idea is not working for me, which is a pain in the neck, because these are a nightmare to peel off. I would have thought duct tape would probably be strong enough to do it, but it doesn't appear to be. Right, so I'm just going to go through and remove all of this backing off all of these pieces, and I will be back when that's done.
One eternity later.
And we're back. Now, slight problem with this, I think is the bottom panel. They haven't lasered all the way through properly, and when trying to pop that one out, that's sheared there and has cracked there. And these two are not lasered all the way through, and so they're going to have to be drilled out. But first I want to see how we're supposed to put this together, and whether or not it's really worth putting together at this rate. Looks like these little allows you to put a nut and bolt through, so I think we have to put a bolt through like that. Then somehow screw that together. So let me find a tiny screwdriver and see. I think the one that's cracked is going to be for the bottom, hopefully, so it shouldn't really matter too much if it is cracked, but yeah, oops. It's just really annoying when they don't drill all the way through, and so we end up with this problem where we've cracked one. Right, let's just see. So I think we put a nut in the slot. That'd be why they supply a load of those. Then bolt through the acrylic. And then tighten that up. So I think that's the idea. You can see, put that in, just work our way around, fit it to there, tree in, etc. So let me just assemble that. Well, we are back, and that has taken a fair bit of time. I've had to drill out a couple of holes here, 3 holes there, and I've loosely put that together with the nuts and bolts. So hopefully we should be able to assemble the rest of it. We've got some here. I hope these are going to poke out. I think I'm going to have to drill these out as well. Yeah, they just really haven't laser cut this very well, unfortunately. It is what it is. So if you do have one of these kits, you may need to do some drilling. So orientation, we've got switch is that side. Now this is where we find that the LEDs don't fit in the case. Oh, come on, it's ridiculous. Really? So it looks like our 2 bottom ones are not going to push in. Right, we're going to have to unsolder those and push them in, and the ones here I think are going to have to go in a bit further as well. I'll be back again. Right, some adjustments to the LEDs later, but yeah, I think as a PCB kit it's okay, but yeah, this case is just, it's just an absolute utter nightmare. I mean, it's only held on with 2 down there. You can't get these corners in. The PCB is virtually touching it. I think maybe if I can do something with that LED there, I might be able to get it somewhat into this case. But yeah, it's just, it's not laser cut properly at all, so you've got to end up drilling bits out. Yeah, I think that's the that LED. I think quite a few of these LEDs, I think maybe if they were mounted not on the side it'd be better, but then that of course wouldn't give the same effect. But clearly, I mean, that, yeah, that one I'm going to have to, I don't think I can bend it over anymore. I'm going to have to try and unsolder that and bend it completely flat to have any real chance of getting this in this case. But yeah, I mean, it does work, but it's just, yeah. Nice PCB for a kit, but rubbish case. Anyway, I shall persevere, and no doubt the thumbnail will probably show the actual thing fully assembled. But yeah, if you want one of these kits, they're on Banggood. I'll put a link in the description below. But yeah, your mileage may vary with this Perspex case. I mean, it's good to have it housed in there, but it's just, yeah, the tolerances are too tight. You look at the size of the base. If they just brought this out nearer, just made these panels that little bit wider, then of course you'd have much more clearance there, which would make things a lot better. So anyway, if you want one of these kits, links in the description below. And thank you very much for watching the video. I hope you have a good Christmas. If you're watching this after Christmas, then I hope you've had a good Christmas, and I will see you soon for the next one. Cheers.